morning. It's still morning. So, Dr. Bhujanga Rao, Dr. Ganesh Kumar, Dean, Dr. Professor Vijay Shekhar, Head of Department, Professor Srinivasan, Professor Satyanarayana. I think we have interacted. Yeah, sorry. All my colleagues, faculties from GITAM, NSTL, fellow students, and industry experts from Andhra University, and whoever present here, also DRDO who has been supporting me all the way. So it's really a great pleasure to be amongst all of you, particularly to interact with the students. I always love to engage because they come with a lot of ideas, young minds. Industry portfolio is changing. When we started mechanical, I think I did 32 years back. It was hardcore mechanical, right? All the machine design. I think many of you are from mechanical. So it's more on practicing the concepts rather than the detailing. Those books of Thereja, I don't know, Chapman. So, So, but things have moved, engineering has moved quite a bit from there on. And when it comes to the industry application, I think it is more about the knowledge, how we apply in the industry, how do we work closely with academia. My last few slides are connected to that. And with the advent, as people have talked about, the Internet of Things, the Industry 4.0, there is a rapid pace of change of technology. So one has to be updated. I always felt that as a mechanical engineer, with every passing year, you have a lot of experience, you become more important to the industry. But like software engineering, computer science, if you do not change with time, you will be obsolete and outdated. So it is also in other fields, be it electrical, with instrumentation, with mechanical, and the metallurgy, everywhere. The technology is getting innovated, changed. There's a lot of idea incubation that is happening. So unless you work closely and keep yourself updated abreast with the changes, you will soon find yourself outdated next thing. So it is important that it is not hardcore. But yes, today it is not only mechanical. Mechanical means it is an integrated approach of digital, it is an integrated approach of software understanding. Mathematic modeling is very important because all what I will talk about is largely, one part is a hardcore, hard-facing sensorization. The other part is how do I draw meaningful insights out of those data. Because data is power. A person who has data is more wealthier, and in this so-called industrial terms. So first of all, once again, thank you and GITAM University and CNSI for giving me opportunity to come all the way here. I was telling to Dr. Bhujanga Rao that when the last NCCM happened here in 2018, the last moment I missed because I had some other engagement, couldn't come. So I was longing to come, but I made it up by coming for a family visit in 2018. I missed in September, came in December, but I came very close to GITAM but never entered. But when I was offered this, I think Mr. Probal Ghosh, he talked about and he was saying, why don't you come? I had to reschedule, but I said, okay, I will definitely make it a point to come here because it's also good to engage with all of you. The most promising minds, the engineering minds that organization the country needs going forward. And particularly as the country is driving for Atmanirbhar Bharat, making India, things all and the way India is progressing, this decade will be for India, that's for sure. So, my topic is more application as what we are applying in steel industry, and with little bit of focus on Tata Steel as a whole, because I believe we have been driving many initiatives. But before that, I think I am extremely obliged to present this endowment lecture. Dr. Bhujanga Rao, I think he is a pioneer in the field of industrial condition monitoring. He has been the father and the founder president of CMSI, and in my past capacity as chief of mechanical, I have been interacting with him a lot, with the society, with Mr. Ganesh Kumar, and so on and so forth. So I was just asking him that I always knew that he has been a very renowned scholar and a very distinguished scientist who fundamentally was with DRDO and STL, and now gradually as one part moved into the medical research. So you can see it is not limited to machines, as Pip said that it is asset monitoring. So it can be anything. Today, going forward, health is of utmost importance. And as what we do, we monitor blood, we're monitoring all these things. Gives you a overall feel ki how is your health. In similar lines, for asset, you need to find out all such parameters to know that if you get a good insight of the condition of the parameter, you know whether your equipment is healthier or not. So thank you, sir, and thank you, CMSI, for giving me opportunity. I'm extremely honored and privileged to give this endowment lecture. And I said, okay, more on practical, very less on the detailing of CM. I hope you will be enjoying the aspects, and we can make this more interactive and the later part, right? So this what is my scope. We will generally talk about. I think some of you might be knowing. You might have heard steel. What is steel? And this one for Tata Steel, JSW, Nippon Steel, POSCO, Arcelor, and so on and so forth. The world, we have a huge requirement of steel, and we have the steel industry, which is traditionally for many years. So I'll give a glimpse of what is the steel industry all about, because as many of you are getting into, what I see, most people are opting for a software, but obviously the world is round. Even the hardcore steel industry requires a lot of software and data analytics. So we'll talk about a little bit of industrial revolution. How do we plan to digitize to deliver better, and be more predictive in our assessment? And we always have point that assets must be smart. It's when we talk of equipment, it's condition monitoring, be it thermography, be it CO gas monitoring. So many aspects. If you want, you can do condition monitoring of everything, every aspect, every object which is possible, and that's where science is working together. The physics and the science are working together with the technology and engineering to develop better solutions for our early understanding of asset health. And then we talk about the smart asset management, what we in Tata Steel are planning to do or are doing. And of course, the last part will be more on how the industry and academia, the students, the research, the R&D, the startups, how we can work more closely. And at Tata Steel, we provide a lot of opportunity to try out new things, because we have been pioneering not only in the place of manufacturing, but in HR, in digitalization, in other aspects. We always have believed in pioneering new ways of working. So, this is a steel industry. Normally, if many of you do not know, we get the ore, and then the iron ore, the coal, all this together. We put it into a blast furnace, and then you need oxygen plants. You have to convert the coal to coke in the battery, and then from iron ore into sinter. And this some ratio it is fed into a blast furnace, and you purge in a lot of oxygen. There's a reduction process. I don't know whether I don't know in the early part of your mechanical engineering. And then when you make hot metal, and then the hot metal is taken into a steel melting shop. When you purge it, very high speed oxygen to convert into steel. Then you need to steel ko dhalai karna padega. You need to cast it in terms of whether you want a flat or you want a long line billets or a slabs. Now when these are intermediate products, the slab and then steel is getting converted into rolling mills. For longs, you have the rebar mills, you have the wire rod mills, which produces the longs and rod, which is primarily in the construction area. And when you come to the flat, we normally produce those. There are two types. One is the industrial application, normally for sheeting and all, where we produce the corrugated sheets, and for the roofing structures and a little bit of fabricated structures from the steel. and also for the automobile. A large part of our supply is related to automobile, and that's where we have a high-end product quality. The JCAP project, which I put up along with the Nippon Steel, was also for making the super quality which is used on the car body, which is the best quality IF steels. So that's how you can see, be it oil and gas pipelines, and you see the kilometers and millions of kilometers of underground pipelines goes across between two continents, where today natural gas or other gases are conveyed. We have the construction, aviation, we have in automobile, we have in shipbuilding, and today is a maritime day, I believe, for National Maritime Day, and it's a very good time to be in Vizag, which is perhaps the leading city in the country, which drives maritime functions. Yeah, so it is a very good coincidence, and so its large part is both in big shipbuilding, appliances which you see in white goods, refrigerator ho, AC ho, anyway. So, and latest is the windmills, because as we know that we have to go for greener to reduce our carbon footprint. We need to be more and more with solar panels and windmills which are coming in to be more green in energy. So now we are working how can we make more steels which are more durable and which are used for the windmills. So you can see the entire, you think of any function, we are always there. I mean, steel is there. So I want to talk about, just not dwell much on this. I just said that steel is versatile, years, hundreds of years. Of course, there is competition, there is aluminium, there is much more lighter material coming, there is a threat is there, but I believe all things cannot be replaced. So steel will have its own place, and it can be recycled multiple times, up to 10 times. And the point is, we need to be using more better resources. How can we recycle the water, more on ZED and so on and so forth. And I think the affordability, the cost of steel is comparatively much cheaper compared to an aluminum or a copper, which is of higher order. So our presence, we are in India, we are close to 20 million, and we will be 30 million. We are 30 million if you look at all the sites. We are at India, we are in 4 sites. Jamshedpur, primarily I come from Jamshedpur. We have a site in Kalinganagar, Meramundli, which is in Angul, and we also have a TSLPL site, and the previous acquisition is NINL. And we have Tata Steel Southeast Asia, which is in Thailand and Singapore. And we have in Europe, which is in Modin, which is in Holland, and Port Albert. So, in a large scale, if you look at on the steel industry, we have a great presence all over the world. We are present in all the 5 continents. You see the footprint in terms of manufacturing as well as in terms of conversion or processing sites. And of course, the mining assets are largely in some Canada, India, and some other places. This is a presence. We have a huge employee base compared to, and these are some of the brandings. You must have heard all the names: Structura, Astra, Viron, and so on, Tata Shakti. So you can relate yourself with all of the brands. We are present all over the country. So I just wanted to say that in a steel industry, particularly any steel industry, particularly our steel industry, in Tata Steel, Jamshedpur, we are a 100 years old plant, plus 115. So if we have such a wide spread of assets which are as old as blast furnaces, which are in 1960s, and also the newest machines which are coming up, you can understand the diversity of automation maturity it has. And one solution strike all is not possible. So you need to think, how do you find a most balanced management process of asset management. Just structural integrity is one of the key areas where your whole structures, how do you maintain them? How do you get early insight? Where do you maintain? There are thousands of structures, and it's not accessible. We are heavily having issues of corrosion and all. So someday it might fall. How do you manage assets? How do you know the health of the assets? So I'll come to that later. Also, many of the assets were not engineered. This concept of digitalization was not there. Maybe a couple of years back. So your assets were not designed to have sensors, so many sensors. Today the assets are equipped with new sensors, with modern sensors, developed sensors. So that's a challenge. But in the whole value chain, you need to understand where do you put what and how do you decide which are the critical assets which drive your manufacturing value chain. Just to give you an idea that this is how there is a level 3 automation, there is also a simple you have power, and I in my 30, 35 years, 32 years of experience in Tata Steel, I have seen the transformation from a basic breakdown type maintenance to conventional, then we went to preventive maintenance, you heard of CBM, condition based maintenance, then we thought let's learn from TBM maintenance, time based maintenance, then we thought that we need to be predictive. You need to tell what the machine is, and we are challenging why machine requires a maintenance. Earlier days we used to have cars, every other day weekend most of us used to go and do some maintenance, filter ठीक है कि नहीं, कि इसमें तेल ठीक है कि नहीं, because we know somewhere फंस जाएंगे तो मुश्किल हो. So that used to be a problem yesterday. Today, how many of us look at the car, we just get it and keep running, and though we don't even know, कुछ फंस जाएगा तो पता नहीं चलेगा what. So that is so integrated with self-diagnostics and so on and so forth. So the technology is changing fast. The human requirements are changing fast. So we also have to keep pace with that if we have to deliver the best at the benchmark level. And of course, we have 350 conveyors, metal handling to make 10 million ton units, 3 times 1 meter, 30 million tons. Can you imagine the magnitude of material that requires to be handled? A series of conveyors, and all has to perform. If one conveyor in the link phase, the whole value chain stops. You cannot afford any plant to stop. So how do we do that? So I think all of you know this. We have talked about it. Industrial revolution 1, 2, 3, 4. But I am saying we all heard we are in 4. But very soon perhaps we have to move to 5. Thoughts are coming in. Industry 1. We knew steam engine. But the usage of steam engine to convert into power and mechanization came in industrial revolution 1, perhaps in the 17th century. So that helps. The spinning करते थे manually and with automation, with mechanization, perhaps it gave you 8 times productivity. Was more focused on productivity. Come industrial revolution 2. Was more focused on how can you produce on a large scale, mass production. Which is building on industry 1.0. So, and then you have brought in cost, the effect of cost optimization and productivity came in as part of industry 2.0. Industry 3.0 was more of automation, the big computers, the IBM mainframe, all of things came in that space. Today, we don't even talk of IBM mainframe. We have graduated further. So it gave you more flexibility, more speed of operation, the computing ability. So all those things came in. But when we are on the threshold of industry, we are in industry 4.0. But this has built on 3.0. It is more on the connected assets, connected people, how do we use technology, how do the internet for a better delivery of our products and manufacturing requirements. So, but we are all industry 4.0. But I believe going forward, it's very soon that we will be moving into industry 5.0, which is more on humanized aspects, more on building resilience, and perhaps the last couple of years of COVID and pandemic has taught us how can we be more resilient, how can we be more robust in our approach, how can we be more pragmatically addressing all these issues, and then that's where the focus will be how to be sustainable, because the nature, water, temperature, climate, that's one part of it. Whatever you do, how can you make it sustainable and long standing. So it is more the next cycle revolution, which perhaps we are on the very foothills of that, is industry 5.0, which is perhaps we are just thinking about it. I mean, the industry must be thinking about it, but very soon you will start hearing this also. It's all about, as I said, agility. How can we do it fast? How can we respond to a situation? How can we anticipate things better in an industry that this is going to happen? You can be reactive, but then if you have to be ahead of race, you have to be ahead of competition. You need to think ahead of time, and you need to be agile in your mindset. You need to be more resilient to think through a process so that it is irreversible. That's where, in 2006 or around that, we never thought of 4G. Today we are talking of 5G, and very much is present in India. We never knew about Android, the iPhones, the Uber, and also the Airbnb. Today, the new generation, of course, the pandemic gave us a hit. But people today feel, why should I buy a car? I will get in and get out. Why should I own a house? So concepts are changing, mindsets are changing. Everything is changing. What took time? 75 years for a telephone to reach, 100 million users. As you see, move down the ladder. In the ensuing years, things became much faster. WhatsApp, 3 years. Instagram, 2 years, and there are many more. I've just put few of them which I know. There are many more products, people are more aware of it. So, the technology is so fast changing. I just wanted to explain that things are changing at an exponential pace, at a rapid pace. And if I live behind, I stay behind that I will not change, then you will not be competitive. You will not be able to move ahead of time. Right? So this is where, so you need to be future ready. You need to think of the future. You need to be responsible. Whatever you do has to have a greater impact, better impact to the society and community at large. You have to be digitally transformed, and that Industry 4.0 ecosystem has helped us to move in that direction. As I said, yes, agile, and above all, you need to be connected. Without being connected, you can't reach out. So how do you ensure the assets are connected? So coming to that next topic, I think I'll just say, having that in mind, what do we need to do? We need to digitize, deliver. If you see, this is the perspective of Tata Steel, how we have changed. As I said in the beginning, it's common for all industry. I mean, if you look, this is just a reference, but if you look at any industry, be it steel or any metal industry, manufacturing, all industry, conceptually have moved in this direction. It began with, we thought of, okay, let's keep running. When the machine goes down, I will put it down for repair. As was the concept focused on repair with optimum cost, so that I minimize my cost. Right? But then we thought, let's start measuring the availability, then we start measuring the interruption, reliability. So as we moved ahead or with time, our concept of maintenance of asset kept changing from a reactive to preventive maintenance, which used to say planned maintenance. We heard so many jargons, preventive, planned maintenance, and so many things we must have learned. But then, that was not enough. We were not knowing. Then we started looking at descriptive, that if a component or it was failing, and say something is failing repeatedly in some time, so we know maybe there is a trend line, so let's change it before that phase. That's what TBM, time-based maintenance. But if you keep on doing time-based maintenance, one is that you may not be giving the optimum availability, and neither you will be able to be at the cost. If your is to give benchmark availability at optimum cost, you just cannot rely on TBM. But yes, it's not that everything in the world has to change. You need to know where do you apply what technology and what philosophy. A thing that has a pattern for varying, that definitely it will vary in a certain time, you change it. So going ahead, we thought that let's now bring in predictability of assets, predictive maintenance. I mean, how do I predict equipment behavior? How do I know that equipment is developing a distress? How do I know that a fatigue is getting developed in the equipment? And for that, you need to have data. For that data to come, you need to have a deep sensorization. You need to understand what type of data is required. And it's not only one data where you will work. It's not only picking up a vibration data. A vibration is an effect which reflects when equipment is already in a bad shape. So how can I pick up a effect much early through a set of data and develop many models in terms of we do some regression analysis, this and so forth, and then we can throw some insights that if the behavior is like this in maybe 2 months time, 3 months time, there is a likelihood of a failure. So we pick up those early warning indicators. That's the whole concept of predictive. But you cannot just sit down and be happy that I know the prediction is there, so I will get the prediction. The world has to move forward. Just by prediction, you cannot be world class. 100% the plant should operate. You should only stop when I ask to stop. No breakdown between two shutdowns. And how do I extend the shutdowns? Shutdown to shutdown time. So there are two objectives. Right. So you have to move towards prescriptive. What is prescriptive? We are hearing predictive. We are moving ahead with prescriptive. That now it will also tell which parameter to adjust and what is related to whether increase in a particular the vibration or some temperature. These are all reflection of some abnormality. How can the machine itself project that look, that particular parameter needs an adjustment and future that will be automatically adjusted to bring down and that's what is prescriptive. And as we have a lot of data which is in structured form, we also have a lot of data which is in RCFAs and all this in unstructured. With the AI and artificial intelligence and the machine learnings inbuilt in it, we now want to build by in the next 10-15 years time, we should be in an era of cognitive maintenance, which is a much higher mature level of prescriptive, which will tell what to do when and what. It's a combination, gives the right balance. So that's the journey, and obviously everything cannot be digitized, everything cannot be sensorized. If you have 4 lakh equipment in a plant, like you cannot put sensor everywhere. You have to maintain this cost. So you need to know where to put what. So that is a strategy. Where do you put the right assets, right? So you have to rely on fundamentals. You have to rely on condition monitoring, which you have to go and get the data. You have to rely on predictive. You have to rely on. So it is a combination of various strategies. It cannot be only one strategy. That you will run the whole plant, a plant like this, which has got so many assets. You just cannot rely on predictive. And then I'm happy the machine will tell me when something goes wrong. So this is the strategy which we have moved in Tata Steel. But the whole concept believes is on, we knew of CVM. You must have read and studied of the condition-based monitoring. We said that over and above, since you are on a platform of IIoT, Industrial Internet of Things, we rather build the how do I monitor on that's the trending. But again, trending will show. But how do I say that a trend, which is being like this, moving in a particular direction, if it's yes moves or not, how can I give an early warning that if I started to move on today, maybe in 10 days or 1 month's time, it will reach my alarm limit. So how do I generate early alerts? So that's where we thought let's coin CBM to CMAR, which is condition-based monitoring, analysis and report, which is more on today if something goes wrong, SMS comes in this that particular turbine there is some problem. You rather look at it because we build models based on the data. So we took 6 months data, 8 months data and build some model which throws a predicted normal that if this is a set of data, this will be a predicted normal. And this is, and then when you actually the model is in run on the machine, then you pick up fresh set of data. The idea is how do you compare the predicted normal and the new normal which is currently running. And with more and more data, with more and more analysis, the maturity of the predicted normal will always improve. Ideally, both should be same. It will never be same. There will always be a gap. That's where the knowledge comes in, technology comes in. As the gap starts to increase, you need to know when do you trigger, what is the threshold that you have to make a plan for intervention. The whole idea is that you are better prepared for any eventuality going forward. We use the logic that whether it has to be in condition monitoring only, which is going to the field, picking the data and then is more reactive. You are going and picking data and seeing. Then the descriptive, which I said that more on TBM and condition monitoring data and failure data, together you work on it and then you get a insight, this descriptive maintenance. We are into predictive models and obviously as we are maturing by 2025, all my critical equipment, 22,000 equipments will be under predictive, and then we graduate into prescriptive maintenance going forward, where we get meaningful insights of what to do. Here we say that machine is going wrong. Prescriptive will tell you what to do where. That's the whole idea the industry is moving, and perhaps we are leading as one of the industrialization in steel plant. So coming to, having said that, I talked about smart asset, right? So we need to think that how do we make the steel plants equipments more smart, more, when I talk of smart asset management system, what is smart? So I picked up the thought from a Google car. You must have all heard Google car, Tesla moving on its own, set up so much of data. So it talks about, it has a self-performance monitoring system. It has got own self-diagnostics. You don't need to see whether the hard time टिकी खोल के देखना नहीं है कि तेल है कि नहीं, या हवा है कि नहीं, या अपना ब्रेक का कुछ प्रॉब्लम हो कि नहीं. So there are so many things. Everything, there is a self-analytics, and that will throw insights and give you more inputs. How do you address these issues? So with the concept of intelligent car, we said, why can't we not make intelligent assets, which will have predictive maintenance, which will have interoperability, because you have so many plants, so many issues, so many platforms. So how do you ensure that an IBM or a Siemens or a ABB or a Hitachi, they interact with each other? So that's the whole idea, that how do we move our assets from currently in line with the automobiles. And that's why we have the predictive maintenance and interoperability and a central diagnostic system. I will not go through this. It's more of a detailing. The next level of details perhaps may not be very relevant at this point of time. But it's more of talking of the real-time condition monitoring and advanced diagnostics. Whatever we are doing in steel plant today, the resource management, when a chain of functions happens, one person who is doing a job, the next person gets a feedback of what is the progress of the job online. So he is better prepared. It's not that I finish my job, the next person does it. And this is where we are now working. That entire maintenance must be, how do I derive my maintenance strategies through autonomous cars? People have talked about airlines. Many of you fly. How many times failure happens? Almost none. How do they maintain? There are only two engines which is driving the whole hundreds and hundreds of kilometers and hours. So what is the level of maintenance they are adopting, and how can we learn from outside in? So we are looking at, one, I talked about the smart car, what are the things which they are doing, and how do I imbibe the technology and analytics from them. The airlines, the engines, when it runs, it picks up all the data. The moment it lands, how many of you know that the moment it lands, immediately all the engine data gets downloaded in no seconds, and quickly they decide and look at the condition on the flight. Engines which are flying over the deserts, engines which are flying over the Arctic, has got a different set of parameters, because there is a cryogenics, there is a temperature aspect, there is a dust. So all these externalities, inputs, are part of the analytics, and everything, the machine maintenance thresholds, the maintenance by our concept, that you don't need to change everything. When they comes the engine, they might know on a particular component, there will be 10,000 or 1 lakh components in the engine. They will know which component needs to be changed, which will ensure the reliability of the whole assets. So we are working closely with, in line with getting the reliability of our airline. How do we bring the integrity of an oil and gas which is subjected to corrosion, and what are they doing to bring their assets more, make their assets more, as far as asset integrity is concerned, where a lot of analytics, a lot of condition monitoring is happening, and of course the smart cars. And these are some of the learning imperatives which we have picked up to identify the thresholds and then decide where do I do what, and what is my the right time to do a right intervention for a machine. So, how do we do that? We select all the assets And then obviously we need to collaborate with technical partners, we need to collaborate with a lot of startups, we are collaborating with a lot of academia. Because we get to know many things are at the incubation stage, getting developed with research and development. Many people like you are working in many areas. How do I connect? How do we connect? We have a TLA, technical leadership areas, and how do we connect with all such academia and industry experts, the domain experts, and how do we bring all of them together? And that's how we are able to work. It's not that at one shot I will change everything. Every technology which is new, we need to adopt. It might be in some industry. How do I tailor it and make it adaptable to my industrial needs? And then we see once it gets established, how do I take it across for horizontal scaling up? So this is the whole cycle which every equipment is going through, be it a conveyor, be it a set of gearbox or a motor, and so on and so forth. This I've already talked about it. I think some of the areas where many of you can relate, where be it a FFT, be it a shock pulse meter analysis for the very slow speed, RPM of equipment which are less than 50, you cannot do vibration monitoring with accelerometer and so on and forth. So we are extensively working with SPM, and we have been able to pick up great insights that very early the shock gets generated and you get to know something is going wrong. That bearing might fail after say 6 months or 8 months, but when it fails, it will damage many things. But with this, we get to know that something, so increase your inspection, you may increase your lubrication, or you may do your interventions, and you can plan your activities. So all these things, be it a conveyor, be it in a motor, or using of camera analytics videos, or in oil temperature, you think of any parameter, analytics is possible, and we are doing it in every aspect. And that's how we are operating at a very high level of equipment availability. And today you don't need an expert to come. During COVID, we couldn't get, some expert had to come to Japan and what. What we do? We set the cameras, and a guy in Japan was sitting there. He has the ability to, on a real time, to remotely adjust the camera, zoom and pan and do it whatever, and give guidance from there. So the whole requirement of on-site supervision experts have been eliminated. Where the expert can sit far away, sitting in Korea, he can give a inside that look through a VR. He can see the whole equipment there, and then he can give an insight. Ye problem hai to look at that. So technology is fast changing. So all condition monitoring analytics which are being used, either in terms of video analytics, remote operation, extended VR, AR, of course with the machine learning and AI, we are having more improved models to give us more better insight that what to do and when to, because steel plants have to continuously run and we cannot afford any failure. And of course, with this, we are using more and more robotics where people cannot go. How do we replace human mind, human presence with robotics, and the entire what the robot is seeing, I can see sitting in my office, and we can give decisions. We can direct the robot to move, be it chimney monitoring or be it inside the pipe, you cannot get in. Today robots can go inside the pipe, they can go inside these cooling tanks, which you cannot even see whether what is the level of scum deposit. So do you really need to clean now or you can extend? Everything is more predictive. So you can time your maintenance, you can time your equipment outage accordingly, plan that way. This is some of the aspects which we are doing. The entire data for the plant is coming centrally. We talked about asset monitoring and diagnostic center. We are centrally located and getting all the insights together at one place. A set of engineers are sitting. You can see all those slides are continuously changing. And we have built models, only anomalies should come. There will be thousands of parameters getting monitored at a central place, one room like this, right? And then we have a command centers, we have a crane command center. You cannot go to the crane, cranes are always running. So all the important parameters of the crane are brought in through various models and sensors, RFID based sensors, and I can see that every health. If you know how a crane operates, there is a DSL on which it gets the power. We get to know some places the DSL was getting hot. Before it can lead to a failure, we get to know and then you attend it. So you can avoid. So every aspect in the plant, we are using this technology. So you can see robot inside a pipe. Can you get inside a pipe? You can't. But today, robo can go and tell where exactly there is a deposition, where exactly the corrosion is, and you can plan accordingly, or you know when I need to do a maintenance, rather than having a surprise breakdown. So breakdown zero. How do we avoid that? But yes, there will be an exception, one or two. Otherwise, इतना सब पढ़ाई किया मैकेनिकल इंजीनियर कभी तो काम में आएगा. So there is a but eliminate. The point is today the opportunities through this your physical work, physical requirement we have been able to optimize and do much better. Fundamentally, where are we going? As I said, you have data. How do we acquire the data? We are putting a lot of sensors. On that, we are having huge data storage. How are we doing it? In the cloud. Then you need to do data analytics. A lot of mathematical models are being used, hundreds of them in-house and also developed. And on that, how do we build the early warning indicator? And the most important is more and more data. What is the cyber security, data protection? So you cannot just leave it like that. A lot of work is also happening in data protection. And then through command centers, we have the visualizations. The experts are sitting there, and there is a view centers where we give insights that what equipment, and the necessary SMS goes to the relevant person that this particular equipment is under this stress. You rather start looking at it. Okay, and this is where we are. So we are gradually moving from offline condition monitoring. That's obviously it will be there from non-critical equipment, but largely all critical equipments are moving in the right side of the corridor where we are focusing more on centralized approach. These are some of the outcomes which, if you are aware of FT and all these things, some of the screenshots which gives you that red that this is wrong, this equipment is this particular component or this nut bolt is becoming loose, rather address that. And this is how we are now working of we have multiple centers. How do we have one integrated approach? Say our blast furnace will have a conveyor, we'll have pumps, we'll have electrical motors. So how can I get a integrated approach? So we are looking at an integrated maintenance center, excellence center, which will be very soon coming in, which give all centers together one integrated approach. And that is how we want to apply more and more, and with better expertise. And you cannot have experts sitting all over the company. So how can we have some special domain experts sitting at one place who looks at this and they give insight that you have to address this issue and fix this issue in this way. And lastly, when we come to academia, we are doing all these things extensively. FEA must be all aware with all these terms. Fatigue life. So many equipments are running. How do I know when is the fatigue? So I can change it before it fails. Do I know? Today, if you work, that's the challenge going forward. We only pick up when the distress starts to happen. That distress might not be at the alarming stage. We are picking up at the alerting stage where there is a good amount of gap between alert and alarm for you to prepare and plan your shutdowns accordingly, and avoid or do some intervention. But bigger problem is that in a component, there are thousands or lakhs of assemblies. How do I know the fatigue life? How do I know the RLA? Which are some of the areas where industry has to work closely with academia, and bright minds like all of you can work closely with us to find a work on some new areas. How do we work on that? The CFD we are now extensively using. We put a pipe and then decide that is getting some stress developed, and then we find there's some failure. How do I do a CFD in critical pipelines and get to know that this is the behavior the fluid will have, and then redesign the pipeline so that you can extend the life of the component? We are doing in this, and this can be taken to the next step. We are using drones to go to the cranes and on the chimneys and all. How do I know the chimney condition before it actually thins and then it gets falls off? We are monitoring. The drone moves around the chimney in a spiral, and in that it picks up all data. Can you imagine? So these are all part of engineering, marvels of engineering. To the next table where analytics are coming in and the data is analyzed, and it says that it can run for 4 more days, whatever. That knowledge has to come. The analytics cannot happen on its own. The operating knowledge, the engineering knowledge, the research knowledge, and the applied knowledge has to come in together to give the direction. And of course, we are using a lot of strain gauges, LPG gauges in structures, which we know the structure is getting distressed. Before it actually creates a problem, we can address that because it's all huge structure, very high. Many of you, if you have seen, we have a steel plant here. If you have seen, it's all very difficult place to work because of the conditions of coke plants, and those areas are highly corrosive. So you need to know the conditions. And of course, going for the last slide, how can we work more closely the industry and academia in terms of nurturing the skill and the knowledge which all of you have, working towards. We need to constantly, if you learn something, you say, I have done my bit. You have to, you learn, you unlearn, and then relearn. If you don't if you're not in the cycle, in the management of change, you will be left behind. So, as I said, the technology is changing, the paradigm shift in the way things are operating, the demography is changing. Okay, the climate is changing, everything is fast change. You need to adapt yourself and be responsible enough to make changes which are good for the society. And of course, digital technology with more and more AI, the manless factories, we are trying in here and there, manless operations, this, that, abnormality detection, EWI, structural life assessment. These are many areas, I think, where work has already begun. We are doing a lot of work. Perhaps there's dirt for more insights, and I think we can do much more going forward. So finally, the whole concept of smart is, this is what it is. Our assets are more system driven, we have better tools for analytics and sequencing the work to do when to do what. Whole premise being from preventive maintenance, which we used to say, to maintenance prevention. Because we have to move from preventive maintenance age old. Oh, hard thing band kare kuch karta rehna na. Move into maintenance prevention. And that's the whole thing we are saying, why machine requires a maintenance. You fill it. There used to be a Hero Honda ad when we were young. Fill it, forget it, shut it and forget it. Run machines like that and you monitor. And you only do when it really needs, so that you give a maximum of time. And that's what generates value. So that's what I wanted to talk about on our steel industry, and this is what our JRE talked about. Thank you.